Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone and welcome to this video, and we will discuss the third part of the end of term coverage for mathematics. In this part we will discuss complex numbers, and I would like to remind you that if you feel confident with the idea of complex numbers, you can skip to the second part of the video where we solve questions, and in this part, the first part of the video, we will discuss the concepts and ideas. So let's start. So our topic for this part is complex numbers, and there are not much topics and ideas in this part. I just want to introduce you to what complex numbers mean. They are imaginary numbers, right? They are numbers that have a real and an imaginary part. For example, if we have 3 plus 4i, now we know I is an imaginary number. I is equal to the square root of -1, which does not exist in the real dimension. It exists only in the imaginary dimension, not in the real plane, but the imaginary plane. So if we have 3 plus 4i, we will have two parts. We will have a real part. So this part is real because it exists in the real plane, and this part is imaginary. And this is the idea behind complex numbers. Scientists in the past used to solve some quadratic functions, and they found that there are some solutions that contain square root of -1. They thought it is not possible. That's why they used I to represent imaginary numbers, which is defined by the square root of -1. And in physics, it is really helpful. Imaginary numbers are really helpful. So this is why we have it. So the first important idea I want to discuss is finding the absolute value of a complex number, and it is really similar to what we did with vectors. So let's have this example again. We have, for example, 3 plus 4i. And to find the absolute value of it, what we will have to do is to graph it. And this is just for explanation. And after you understand it, then you can, of course, do it without graphing. And it will not be a y versus x graph, but it will be a complex I versus a real plane. And then what do? We will graph the first term here, which is the real part. So we'll go 1, 2, 3 in the real part, and then we will go 4 on the imaginary part. So 1, 2, 3, 4. And we can draw a line. So let's do it. So a line from here all the way to here. How do you find the length of this line? Basically, we will take the Pythagorean theorem, right? We will use the Pythagorean theorem, and it's going to be the length of this side here plus this side under the square root, of course. So it will be something like this. So the absolute value, I will denote it with AV, is actually equal to the square root of 3 squared plus 4 squared. And the answer is 5. And this is how we find the absolute value of a complex number. Now the second part is finding the product of complex numbers, and it is extremely easy. Let's take an example. If we have, for example, 4 times cosine 30 plus sine 30 times, let's say, 2 cosine 60 plus sine 60. And I forgot one thing, which is I. And this made it really a complex number. So the first step is to multiply the coefficients or the constants here. So 4 times 2, I will leave it here. And then the answer should be cosine of 30 plus 60. So what we will do is basically take this angle and this angle with the cosines and add them together. And then I will add, of course, I, because this is going to be the complex part. I, and I is with the sine, and then sine, and again 30 plus 60, right? And we will get an answer. And this is our answer. Now, of course, we can simplify it because we know cosine 90 is equal to 0. Therefore, the answer is 8i sine 90, and sine 90 is also 1. So the answer is 8i. Now let's talk about converting complex form all the way to rectangular form. So let's consider this situation where we have, for example, 4 times cosine 45 plus I sine 45. How do we convert it to rectangular form? In rectangular form, we really want to have only numbers. We don't want to have any trigonometric function here or trigonometric value. So the first step is just simplifying it. So I will multiply 4 to both sides. So we'll have 4 cosine 45 plus 4i sine 45. And then using our calculators, we will just have 4 times cosine 45. Let's find it. Now we know cosine 45 is root 2 over 2, and we'll have 4 here, plus 4 times sine 45. What is sine 45? Also root 2 over 2. So 4 times I times root 2 over 2. And then we go ahead and simplify. So 4 root 2 over 2 is 2 root 2, plus 4i times root 2 over 2 is also 2i root 2. And this is our answer. We converted it into rectangular form. So let's start solving some questions, and I think we solved a similar question to this. Of course, to find the absolute value of some value, for example z here, so z, an absolute value, is taking the Pythagorean theorem of these values. So again, 4 squared plus 3 squared, and the answer is 5. This is the absolute value. For this question, it's similar, so we just plug it into this Pythagorean formula. And this is our answer. Again, the same idea. And this is our answer. And this one is also, again, the same. And this is our answer. So to solve this question, we do the same steps that we discussed previously, and for those who skipped the videos, we will do these steps. So let me rewrite the question here. So we have 2 times cosine 5 pi over 3 plus the imaginary part sine 5 pi over 3 times 4 cosine pi over 6 plus I sine pi over 6. So to find the answer, we will multiply these two constants here, 2 and 4. So 2 times 4, and then cosine, we will take this part and add them together. So we will have 5 pi over 3 plus pi over 6, and then plus for the imaginary part, and for sine we will take this part plus this part. So 5 pi over 3 plus pi over 6. So let's solve this. 2 times 4 is just 8 cosine of 5 pi over 3 plus pi over 6. That is just 11 pi over 6. And then plus I sine 5 pi over 3 plus pi over 6 is also 11 pi over 6. Let's put brackets here as well. And this is our final complete answer. Now for this question, to express this in rectangular form, we just have to simplify the cosine and sine. So let's do it. We will have 8 cosine 11 pi over 6, 11 pi over 6 plus I sine 11 pi over 6. And what is cosine pi 11 pi over 6? Let me use my calculator here, and I will make sure that it is in radian mode. So I'll write here cosine 11 pi divided by 6, and the answer is root 3 over 2. So this is root 3 over 2, and I presume sine of 11 pi over 6 is 1 over 2, and I will check it in the calculator, of course, to verify it. So we'll put here sine 11 pi divided by 6, and it is not 1 over 2, but it is negative 1 over 2. This is for this part. So let's simplify. We'll have 8 cosine, not cosine, but root 3 over 2 plus I times negative 1 over 2. And to simplify this, we'll just multiply 8. We will distribute it. So 8 times root 3 over 2 is just 4 root 3 plus, of course, I times 8 times negative 1 over 2, which is negative 4. And this is our answer. Let me write it more neatly. We'll have 4 root 3 minus 4i. So this is it for this unit. It's quite simple. There is not much to talk about. It is very easy. And again, if you have any questions or comments, please feel free to contact at any time. Thank you very much.